So can you tell us a little bit about this new technology and how it actually interfaces with the standard prosthetic limb?
So we bring in the standard prosthetic limb, and because sensation hasn't been available, most of them don't have sensors on them. And so we basically have added this lab system on the top where we can record or sense how much pressure a person is putting on an object when they grab hold of it. And then that is recorded on a computer, converted into a neural code, if you will, a neural stimulation. And then we run that through a set of wires that go in the upper arm. And then underneath the skin, they go to a cuff electrode that's then placed around each of the nerves in one of our subjects in the forearm and the other one actually in the upper arm.
And how do you modulate the current going through the electrode in order to give that sense of touch?
We actually think that's one of the most interesting parts of this work that we've done, is that when we began stimulating with a very regular pattern of pulses, people would feel the sense of touching something, but they would describe it as a tingling, as a paresthesia, if you will. It's like your hand waking up in the morning, that pins and needles effect. They liked it because they felt their hand. They actually were very encouraged about that. We wanted to get a little more sophisticated. And so what we've done is we've begun varying the strength just slightly. And what we believe we're doing is that we are then changing the activation of different axons in different ways within the hand. And so that information then is translated to the brain, which interprets it as a more natural input as opposed to this abnormal regular pulsing. We have placed electrodes around each of the three main nerves that go to the hand, which are the median, ulnar, and radial. And so the median has the first three digits of the hand, the ulnar has the ring finger and pinky, and the radial has the back of the hand. And so around each of the nerves we've placed 8 little electrical points. And when you turn those on, each of them gives us a unique location on the hand.
So what type of tasks can the amputees now do with their prosthetic limb which they couldn't do before?
One that we're pretty certain of now are things like delicate tasks. So for example, we look at cherries. And the nice thing about cherry, even though it's sort of visual, is that if you squeeze too hard, it crushes. If you don't squeeze hard enough, you can't pull the stem out. And so even with vision, they weren't able to perform that task particularly well. When we turned sensation on, they were able actually to do it almost perfect every time. And so it makes a big difference where they can do it. The other thing that they couldn't do before, which is very interesting, is just feel somebody else's hand. And when we asked our subjects, what do you really want to get? Function's great, but they want to hold, for example, their spouse's hand. And when we would talk to some of the subjects or their spouses, they would say, I don't let them hold my hand because it hurts. And so now, when they get the sensation, they feel touching something. And so that's what they've been looking for. It's just that interaction, that human interaction of touch again, which is how we interact, communicate, and explore the world.
This is the first long-term study to have shown sensation over, I believe, 2 years, right?
Correct. So that's why we're really excited as well, is that there's been reports of other interfaces that have given sensation, but they've been short-term. And then this is the first time it's been applied and shown that where they feel the sensation has been basically the same for the last 2 years. So we believe that this is a long-term, repeatable, reliable interface to the nervous system.
And apparently this new technology also helps with phantom limb pain, which I believe is a major problem for amputees.
Yeah, both of our subjects came in and said that they would have debilitating pain. You can imagine your hand. One would describe it as a vice that would continue to crush his hand until, in fact, he felt the fingers were going to go through his palm. They said, keep going, until they did. And then you can't rub it. It's just not there, so it's just pain. And so for us, we didn't study pain per se, but both of our subjects have reported that since we've done the stimulation, they've basically 90–95% are virtually pain-free. They don't have that any longer, and they've been very grateful for that.
And so what are the next steps for you and your lab and this fascinating new technology?
Right, so the first electrodes we put in, we mentioned 8 contacts around each nerve. That was just a low number. We wanted to get to see what we could do. So we believe, because every one of those was unique, that we can begin to increase that number of electrodes around there in the way we do the stimulation. So we've taken these stimulation patterns that go to touch, and we've seen that we can get more complex sensations. We're actually working with colleagues to really understand that and take that to the next level where we can maybe feel silk or sandpaper, whatever they happen to be touching. And then the last thing we're doing is this has been in the lab. And it's really interesting. One of our subjects one time said as he was leaving the lab, he says, as he was taking his prosthesis with him, he says, well, I hate leaving my hand here. And we thought, wow, that's kind of interesting. And the fact that he wasn't going to feel his hand was what he was referring to. So even though he had a tool, the prosthesis, he didn't feel like he had his hand. So we want to get to the point where they can now take sensation home with them, a system that they can use outside of the laboratory environment and every day.
Dr. Tyler, thank you so much for joining us today, and congratulations on a landmark paper.
Thank you.